Hello, I welcome you all. The problem reads, in the case of emergency, the gas actuator is used to move a 75 kg block A by exploding a charge seen near a pressurized cylinder of negligible mass. As a result of the explosion, the cylinder fractures and the released gas forces the front part of the cylinder A to move B forward, giving it a speed of 200 milliseconds. Millimeter per second in 0.4 seconds. If the coefficient of kinetic friction between B and the floor is 0.5, determine the impulse that the actuator imparts to B. This problem is coming from the Engineering Mechanics and Dynamics of 14th edition by R.C. Hibbeler. So to start with, let's draw the free body diagram. We have the weight like so. Right. We have the weight. We have the normal force. We have the friction. It's the same thing here. Movement has taken place. We have the normal force, and then we have in here we have this force. Okay. Right. So this is W. This is Fk. This is N. This is W. This is Fk. This is N. This is the applied force. Okay. Right. So we are going to use the concept of impulse, linear impulse and linear momentum. So we have integral of A dt equal to m v final minus v initial. Okay, so what do we have there? Let's find what n is, so we can apply the summation of forces in the y direction like so. But we know to say this is equal to 0. So we have n minus w equal to 0. Therefore, n is just equal to w, which is just equal to 75 by 9.81. Therefore, what do we have here? So all these we can write them as, so we'll have f minus fk times delta t, and this is just equal to m v final minus v initial. Okay, our fk is just equal to mu k by n, which is just equal to 0.5 by n we found it as 75 by 9.81. Then we do have our delta t. This is equal to t final minus t initial, or just t minus t. T minus t initial, and this is equal to 0.4 minus 1, minus 0. Okay, therefore our delta t is just equal to is equal to 0.4. Alright, our v final is equal to 200 times 10 to the power negative 3, and our v initial is just equal to 0. Alright, so writing this, we are going to have the following. We'll have the following. So we'll have v, this is going to be equal to f delta t equals to m v final minus v initial okay, plus fk delta t. Okay, So our F delta T is just going to be equal to I, which is equal to M. Our M is equal to 75 kgs. So we have 75. V final is 200 times 10 to the power negative 3 midi minus 0 plus Fk, which is just 0.5 75 by 9.85. I mean 9.81. Therefore, F delta T is just going to be equal to I, and this is just going to be equal to 75 by 200 times 10 to the power negative 3 plus 0.5 by 75 0.5 this one times 200, I mean times 0.4. So 0.5 by 75 by 9.81 by 0.4, and this we get 162.15, and the units are newtons second. Okay, so this is the impulse that is imparted on B. Okay, this is about it, and I hope this particular video was helpful. And if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and I'll see you in my next screencast.